Hi, this is Mrs. Wiederholt, and welcome to my lesson video on the introduction and graphing of absolute value functions. Now let's get started. The absolute value of a number is its distance from 0 on the number line. For example, how many units is 2 from 0? Well, that's very simple. It is 2 units from 0. Now let's go on the other side of the number line, on the other side of 0, and how many units from 0 is negative 2? Well, you're right. It's 2 units. So that's what the absolute value is. It is merely the distance from 0 that a number is on the number line. So we have just shown that distance is always non-negative. So that means the absolute value of a number is always non-negative or positive. Okay, the symbol used to represent the absolute value of a number is 2 bars. And then the number or the expression will go inside. So this is the symbol used to represent the absolute value of a number. Now let's look at an example. If A equals 4, then that means the absolute value of 4, which is written like this, would be equal to 4. Basically what we're saying is the distance from 4 to 0 is equal to 4 units. If A is equal to negative 4, then that means the absolute value of negative 4 is also equal to 4. Again, it's like we're saying the distance from negative 4 to 0 is 4 units. Now you try the next one. Pause the video and then come back and we'll discuss the answer. Okay, if A is equal to 6, then that means the absolute value of 6 is equal to 6. And if A equals negative 6, then the absolute value of negative 6 is also equal to 6. Now let's look at graphing absolute value functions. The parent absolute value function is graphed below, and the equation is f of x equals the absolute value of x, or y equals the absolute value of x. Now the absolute value function forms a V shape. And this is because it is actually 2 separate linear functions. Now on the left side of the absolute value graph, this one right here, this is y equals negative x. And this part of the absolute value function is y equals x, which if you remember is our parent linear function. Now let's fill in these blanks by looking at the graph. So when x is positive 1, that's right here, what is the y value? Well, the y value is also positive 1. When x is negative 1, what is y? Well, as we see, y will again be positive 1. Now let's look at another example. What about when x equals 4? So let's go to the right 4 units. And to get to our line, we have to go up. How many units? We have to go up 4 units. So when x is 4, y is 4. Now let's find out what y will be when x is negative 4. We go to the left 4 units, and we go up. How many units? We go up 4 units. So when x is negative 4, again, y will be positive 4. Now let's look at some of the characteristics of the absolute value graph. First, let's look at the domain. As we can see, this graph, if you're going towards the left, is going towards negative infinity. That's what our domain is going towards. So, and we look at this side, the right side of the absolute value graph, we see it is moving towards positive infinity. Therefore, our domain would be negative infinity to positive infinity. Now for the range, remember that we always start at the lowest point and we're moving towards the highest point. And our lowest point is 0, 0, the origin. And so what is the y-coordinate of that lowest point? Well, it's 0. So our range is going to go from 0 towards infinity. Now, the axis of symmetry might be a new term for some of you. Axis of symmetry is another way of saying the line of symmetry. Where could the line be drawn to make the left side and the right side be symmetrical? And for the parent absolute value function, it's going to be the vertical line where x equals 0. For absolute value functions, the axis of symmetry always goes through the vertex. And if you look at the coordinates of your vertex, in this case, our vertex is 0, 0. The axis of symmetry will always be the x-coordinate of that vertex because it's a vertical line going straight through the x-axis where x equals 0. Next, let's look at the intercepts. Now, intercept means where does your graph cross or touch the x or y axis. In this case, our graph is only touching the x and y axis at the origin. So our x-intercept would be x equals 0, and our y-intercept would be y equals 0. Finally, we get to the vertex. Now, we've already discussed it. The vertex of the parent absolute value graph is at 0, 0. In general, the vertex will either be the lowest point of your graph or the highest point. It will also be where the axis or line of symmetry goes through. So our vertex is 0, 0. Now, I hope this video has helped you to understand a little bit more about graphing absolute value functions and about absolute value functions themselves. I look forward to working with you again. Bye-bye.